Graphing the tangent function. First, let's evaluate some tangent expressions by looking at the unit circle. Part A here in this warm-up asks me what is the tangent of pi. So I'm going to go back to my unit circle. Remember, pi is located here. This is 0 as well as 2 pi. At the top we have pi over 2. At the bottom 3 pi over 2. Remember, to evaluate tangent, I have to know the sine and the cosine and divide. Sine divided by cosine. At pi, I can refer to my unit circle over here at pi. Remember, cosine is the first coordinate, sine is always the second coordinate, so it would be 0 divided by -1. So 0 divided by -1 is equal to 0. Tangent of pi is equal to 0. The same thing happens over here at 0 and 2 pi. So tangent of 0 is also 0. The two angle measures at the top and bottom of my unit circle at pi over 2 and 3 pi over 2. Remember, your unit circle, I need to divide sine divided by cosine in order to evaluate the tangent. So this is going to be 1 divided by 0, and down here at 3 pi over 2 it's -1 divided by 0. So when I do that, I end up with a problem because I'm not able to evaluate any further. Having 0 in the denominator of a fraction always means that my answer would be undefined, because this is not possible for us to evaluate. We write the word undefined. So we've said from the very beginning that my tangent values are undefined at the top and the bottom, and tangent is always equal to 0 on the sides. Tangent's undefined at the top and the bottom, and 0 on the sides of my unit circle. So why is tangent sometimes undefined? It is because I end up with this. When I evaluate, I end up with 0 in the denominator of a fraction, and this itself is undefined. So how does something that is undefined show up on my graph? We saw this a lot when we did our rational functions, and rational functions had things like this that show up horizontally or vertically, or sometimes both. And so when I see something undefined and I go to my graph, like my coordinate grid, in order to put values there and connect a graph, the undefined places are going to show up as asymptotes. So the graph of the tangent function has asymptotes. They are vertical asymptotes, and they repeat infinitely, just like the curve does. So for my function tangent of x, the parent function looks like this. We have what we would call the point of inflection here that goes through the origin, and then the graph itself is a bit of a wiggle that goes through that point of inflection. And then there are asymptotes that are located every pi units, because it's undefined at pi over 2 as well as 3 pi over 2. So every pi units I have another asymptote. So that changes some of these key features for the parent graph of tangent. And let's take a look at what those things are. Okay, so here's the parent graph. Now the transformational form is pretty much the same that we saw with sine and cosine. However, I have tangent here in this spot. The A value, whatever number is here, is going to tell us about a stretch or a shrink, a stretch or a shrink that the graph's going to go through. But as far as amplitude goes, if I'm asked for, and this is not written correctly, none would equal amplitude. Okay, the A value is something different. The A value is just a number that gives the vertical stretch or compression. So there could possibly be a number in that position, and that's not going to it's not going to change what we are going to graph in our class here, but we do always want to make sure to identify that there is no amplitude for tangent. The reason for this is the amplitude describes is a distance. An amplitude is the distance from the midline to the maximum or from the midline to the minimum. And notice that our tangent graph, there is no maximum and there is no minimum. These graphs stretch infinitely to positive and negative infinity. So they do not have a maximum or minimum, therefore they do not have an amplitude. So make sure we understand that A and amplitude are two different things. The value of A is the number that's in front of the tangent. The amplitude is the value of the distance between the midline and the max, or the midline and the min. Excuse me. And since I do not have a max or a min with tangent functions, I do not have an amplitude. The period is also different than what we've seen in sine and cosine graphs. The standard period for the parent graph is pi units. Because every pi units, I have a new asymptote. So in order to find the period, this is the formula that I will use. It is pi divided by b. For sine and cosine, it was 2 pi divided by b. But for tangent, in order to find the period, I use the b value, but I use this formula, pi divided by b. C is my phase shift. It's going to move left or right in the opposite direction that the sign indicates, and there is nothing different about this from my sine and cosine functions. And then the d value will tell me my midline, and the midline is here on this graph. The midline here is, for the parent graph, is at y equals 0. It goes through the points of inflection for my graph of the tangent function. Okay, so now we want to go to the calculator and take a look at how to type in these values and draw a graph. At the bottom of this page, there's the window settings that we'll need. Notice that it is different here, the scale that we're going to use for my table and for my graph. The scale is different. The other values are the same that we used for sine and cosine. So go to your calculator, make sure that you are in radians mode, then use the window button, and let's type in -2 pi, +2 pi. On the x-axis, we want to use a scale of pi divided by 4. Y, max, and min, we can put in -6 to +6. And then let's go over to the table set. Table set, remember, is the same button I use for window, but I just need the blue key first. We'll start at 0, and then let's count our table with a scale of pi divided by 4. So we'll have the same scale on the table and the graph. All right, let's type in tangent of x and graph. So notice that the asymptotes are not shown. We've known that before when we graphed our rational functions. Remember, it does not show up, the asymptotes do not show up on the graph. However, you do see how the curve is repetitive and you see where the asymptotes should be located. So then when I go to my table, let's take a look. So second table here in blue, you'll see the values. Now this is going to be pi divided by 4. This is pi divided by 2, 3 pi over 4, and this is pi. So I can fill in the table that I have on my paper, and these places where it says error, this indicates the asymptotes. Error because we can't calculate a value to put in that spot, and that's where I'm going to have an asymptote. So over on my paper, I'm going to go up to my graph and fill in my table. 0, 1 at pi over 2, it is undefined. -1, 0, and 1. Okay, so let's plot these points. At pi over 4, I go up to 1. At pi over 2, I have an asymptote. At 3 pi over 4, I'm down at -1. At pi, the point is at 0. 3 pi over 4, I'm at +1, and then another asymptote. So I get to see this full curve here, and the table doesn't extend to any negative values, but hopefully you can see that at negative pi over 4, it should be at -1, and then we would have another asymptote here at negative pi over 2. So that kind of helps us. This would go this way. Okay, the period comes from the formula pi over b. The b value, remember, the b value is located here right in front of the x, and it is 1. So that means the period for the tangent of x function is pi. Amplitude, there is none. This is going to be tricky. Keep it remembering that there's no amplitude. The a value would be found here. I don't see a number there, but there is a number there. There's an understood 1 in front of that. So the a value is 1, but the amplitude is none. So make sure that you know the difference between the a value and the amplitude. Now let's go mark the midline like they've asked us to do. The midline is going to go through these points of inflection, and it would be y = 0. Okay, so now let's take a look at what happens if I have a negative in front. So the function negative tangent of x, let's go back to our calculator. I'm going to insert a negative here and graph the function of negative tangent of x. Notice how the wiggle is going in a different direction. So I can take a look at my table, and when I go to fill in, I'm at 0, -1, so still the same exact points, right? The same exact points that I had I don't know what I'm saying. That was ridiculous. The same exact points, but they're not the same coordinates. They're in a different order. This would be 1, 0, -1. So at 3 pi over 4, I'm at positive 1. Pi is still 0. 5 pi over 4 at negative 1. So let's add in this asymptote here. And we get a chance to see our wiggle. It turns a different direction. So to fill in the key attributes for negative tangent of x, so keep in mind that that means the a value would be negative 1. The a value is negative 1, indicating a reflection, but the amplitude is none, because the amplitude means the distance from the midline to the maximum, or midline to minimum, and we don't have a maximum or minimum. So let's definitely go ahead and mark the midline. The midline goes through those points of inflection. And then the period, this is like a parent function basically, because I have the b value of 1. The period is pi over b, so that would be pi over 1, which means my period is pi. Okay, let's go to another example here. I'm going to go ahead and label and fill in the key attributes. I do not have a C, but I do have a D. So even though the A value is 2, the amplitude is still none. Amplitude will always be none for tangent graphs. The period is pi over B, and the B value is 1. The D value is positive 1, so my midline is going to be at y equals 1. All right, let's go to the calculator and type this in. Doesn't look much different, but it has shifted up a bit. So 1, 3, and then my asymptotes. So at 0, I've shifted up. At pi over 4, I'm at 3. Mark the asymptotes with a dashed line. Make sure you're doing this with a dashed line and not a solid line, because these are not part of the graph. They're just marking the places where my graph has asymptotes. Fill in your curves, and then let's mark the midline. The midline goes through this middle point here, the middle point or the point of inflection. Okay, there's several here for you to practice on. Go down to example 3. It's important to make a change here on example 3. That denominator is not going to work with the scale and the graph that we have. So on example 3, if you would change that denominator from 2 to 4. So pi over 4. And then I would also change this to -1. So 3 tangent. To x plus pi over 4 minus 1. Okay. If we go over to examples 6 and 7, just filling in these key attributes, let's take a look. I'm going to label A, B, C, and D. A, the amplitude is 2. No, excuse me. Gosh, I said the wrong thing again. Rewind. Sorry. The value of A is 2. The value of A is -2, to be completely honest, but the amplitude is none. So super tricky, but be careful with that. If they ask the A value is -2. They didn't ask that, they asked the amplitude. Amplitude is none because it doesn't exist in the graphs of tangent. Period is pi over b. Pi over b is my formula. My b value is 1/2. So this would be pi over 1/2. So I have to do the division. Pi divided by 1/2. So that means pi times 2 over 1. So I get a period of 2 pi. The phase shift moves in the opposite direction that the sign indicates. So minus tells me my phase shift is moving to the right. To the right, pi over 4 units. The midline, we use the value of D, and that is 3, so my midline is y equals 3. Okay, example 7. Amplitude is none. Period pi over b, so that means my period is pi over 2. Phase shift, this is a plus here, so that means it's going to go to the left. Left pi over 2 units. Midline y equals -4. There's some more practice for us. There's even a checkpoint available. And the answer key for all of this will be located on Canvas as well. And I would just skip over example 3. I know I asked you to change it, but just completely skip over it altogether. And then practice and check the answer key, please. Thank you.